very much. Well, hello, everybody. It's great to be here. I'm actually presenting this from Tampa, Florida, and it is very early here for me, especially at a Saturday, 9 a.m. to be specific. But at least I'm getting an early start to my day. I should get a lot more done today than I would on a normal Saturday here in Florida. I'm very happy to be here. This is a great conference. We have a good turnout here. We're going to go ahead and get right into the content. The very first thing I'd like to do is introduce Ryan. Ryan, say hello to everybody.
And Hi, good evening, good morning, good afternoon to everybody. Thank you for being here.
All right, cool, Ryan. Thanks. So Ryan's going to be helping out with the Q&A. So if you have a question, as we already talked about, go ahead and just post it in there. We'll do that. I will pause I've got like about 3 sections to the presentation. I'll pause at the end of each also to verbally see if we got any exchange of information we want to share, so that'll be fine too. I would like to do this first, do a little bit of a poll. So if you can go out to slido.com or just scan in that URL. We're going to go get kind of the mix of the audience here so I can guide the presentation accordingly. So let me go ahead and show you that once again here. And once we get a few folks on here, we'll go ahead and start the first poll. And we have a lot of great information here for you today. We're going to be covering a few use cases that developers should be aware of blockchain type solutions. Then we're going to go into lots of the tools and lots of demos. So we got a lot of good stuff here going on. So let's go ahead and get you all going here. I'm going to actually do this as well here. All right. All right, let's start the poll. So are you a developer is the first thing I would like to know here. Yes, no, and sometimes. So we're getting a good number here. About 7 of you have responded so far. We'll see if we'll hang here for a second or two, get some more folks on board. So it looks like it's, we got our crowd here, Ryan, today. It looks like either they are, yes, are developers, or sometimes they are developers. So that's a good piece of information. Let's go ahead and go to the next question. Oh, right here. So how experienced are you with Algorand blockchain? Number 1, I'm brand new to blockchain, period. Number 2, brand new to Algorand blockchain. 6 months or less with Algorand, and more than 6 months with Algorand. So those are the ones. So brand new to blockchain, period. 80% coming in on that one as well. All right. All right, that's good to know. Thank you very much for answering that one. And the last poll that we have is what programming language. Choose a multiple choice, so check all that apply. Do you typically like to code in? And we got Python, Java, JavaScript, C#, other, Go. All right, the choices. Good number of you, kind of split between JavaScript, Python, got some Java devs too. All right, good. Give me an idea of what languages to kind of demonstrate today, because we got multiple language support in a lot of our SDKs. And I want to thank you very much for participating in that. And let's go ahead and get back over to the deck. Thank you very much. All right, let's begin this session. So many of you indicated that you are new to not just blockchain, but not just Algorand blockchain, but blockchain in general. So what we want to talk about here is the possible solutions, right, for blockchain, just getting a good understanding of what are some of the use cases that can be utilized for a blockchain type solution. Also, what are the features for developers that might be interested in? You all seem to be doing development type work, so that'll be a good piece of information for you. And what's my toolbox? What are my set of tools that I can use to develop blockchain solutions with? And then how about just getting started? How do I go ahead and get started? Well, we'll keep you on the edge of your seat there and give you some information as we go through the session and get you information about how to get started. And what about just building solutions? I want to get going and start building some solutions. We'll talk about that as well. And brand new to blockchain, well, there is another video I could recommend that I rolled out a while ago on YouTube on the Algorand channel. Everything you need to know, and that has an in-depth section on like an intro to blockchain. I will also verbally do that here today, given the fact that we also have a lot of folks that are new to blockchain, period. So first, let's start out with some blockchain use cases. And a couple of the use cases that I like to talk about, the first one is props network. And what the props network is, it turns app users into loyal financial stakeholders. And the props platform attracts blockchain technological complexity for apps. In other words, they have like a widget. They also have an API that is available that really revolves around loyalty programs. It's SEC approved tokens. So the token is the key part of that line. And we'll talk more about how you create your own tokens in a minute. It's an ecosystem for these token holders. And also, the video is up on our site regarding their journey, right? Going to the Algorand blockchain to provide this type of service and this type of solution. Now we have more information up at our use cases sites on the props. The second one here is a Circle and Coinbase. They have merged forces to create the Center Consortium. And this revolves around payments and treasury infrastructure for the internet. We've got Circle, Coinbase, and once again, Center. It really is what we're talking about. And the deal here is they accept payments, all kinds of payments, send payments, payouts globally, could be through banks, could be through credit cards, but also in addition to leveraging traditional payments, they can go through blockchain infrastructure, which then provides this globally and scalable, and it's very efficient. So now you've got, over 2.2 billion people on this planet that have black access to modern financial services. And by using something like blockchain, you're going to be able to reach everybody on the planet. So this is really a good thing for humanity. And I really feel great about this job I have here at Algorand and helping people, right, get to that point. USDC is the fastest growing stablecoin, 2.3 billion in circulation. So another really cool thing about the Central Consortium. Once again, more information up on our site. And really, in general, DeFi apps are exploding in 2020. There's $20 billion worth of crypto dollars and stable coins floating around. We talked about a few of those, but IDEX and stable coins like Tether and USDC and MELD are available. For those that are unfamiliar with stable coins, it's basically they're tied to a fiat, so it could be tied to USD, could be tied to a country's currency. So the problem has been in the past that cryptocurrencies really fluctuate quite a bit, and with stable coins, it will fluctuate with the local economy, basically, which is typically a lot smoother. So that's a really great solution in terms of using the blockchain, and there are many other use cases. It's not just financial applications. I want to be very clear about that. It could be used for charity organizations. Maybe in this case, this was taken from a blockchain report from China for 2019 and 20. And the ministry there is using blockchain right now, right, to improve transparency of social services. The problem is, back, 10, 12 years ago, there was a big misuse of funds of Red Cross at one of the earthquakes. They didn't know where the money was going to, where it was coming from. Basically, in short, it lacked an audit trail. And by having a blockchain, and those are really brand new to blockchain, and many of you are basically, it's a read-only, write-once ledger or a database. And the idea here is there's a very strong cryptographic hash algorithm that goes from block to block, and you can think of a block as a set of records that revolves around accounts and transactions and assets. So we're going to be covering a lot of that here today, but that's really the background, really, that I wanted to kind of lay the ground with in terms of what blockchain really is. And it's a distributed database. Everybody's got a copy of it. So the beauty is it has things like audit trail built right in. And it's very secure. It's easily detectable if anybody's been tampering with the data. So that's another big feature. So transparency, audit trail, and easily detect tampering. Probably the big three things. Another area would be like a voting system. It's tamper-proof. It's built right into the technology. Healthcare, having global access and medical records. I go to a doctor and a new doctor, and I gotta spend a half hour filling out all the information, all my medical information, my medical records. Well, wouldn't it be nice just if I was in control of that and I could say, okay, here's my information that only I can give out to anybody I want to. And then boom, here you go. Now you got it. And, I can get in the office a lot quicker to see the doctor. So, but, more importantly, people are not always able to provide that information. Maybe they're severely hampered or injured or handicapped. And so this would provide a really great service for that type of a use case with healthcare. And finally, there are many examples, but automotive is another good one with supply chain visibility. Any supply chain solution, again, another great candidate for working with blockchain. It could be in this case about vehicle integrity. China's putting in sensors into used cars, right? So they know what the service record would be from that point going forward, and it reports that all to a blockchain. So this could be revolutionary in terms of the automotive industry, and so many more use cases for blockchain. So many more use cases are documented up on our site. You can see few other ones there, like asset block is a tokenizing real estate asset approach. So if you have a hotel, for example, and you want to parse out ownership to many folks, you can parse it out with tokens or assets. Planet Watch, another one that's been very big of late. World Chess we got on our list. USDC we had mentioned, Republic. So these are all big companies that are now coming around. In fact, Algorand's growing ecosystem is really getting to be huge. We are expecting by the end of the year, to have several people, like over 10 million users on the blockchain, estimating 1 million transactions per day. So that kind of summarizes the use cases. I'm just going to do a quick demo here. We talked about crypto tokens. Well, what we see here is a tool that can create these tokens visually. And this is referred to as an Algorand standard asset or an asset manager. And this is done by just simply going, this is Algodesk.io. This is a partner had created this particular solution. And all you do is hit the asset manager to create your own token. This will be your private key. You should copy that off, and then you could restore your account at any time. And this is all done on testnet environment to start with. And I'll talk about the different environments as well. So now I've got this asset created. If I go down here or the account created to build my asset with, so I'm going to hit the create asset, and then we just go to the asset name, the unit name, which is a more condensed, and then you have the total supply of these tokens. So you can create your own coin, basically. I'm going to go with 10,000, and then I also want to have a decimal point. So it'd be 10,000.0, is the amount that's represented on the blockchain. And this would be my URL.com, let's say, and then accept all the defaults for the rest. And then you just hit create. And now, boom, you're going to have your own token created just like that. And then we come down to the bottom here, and we'll see the information about this this displayed here. This is this RUSC unit. You've got the ability to do sending this asset to another account, modifying it, freezing it, even clawback or revoking it and deleting it. These are all things that can be done. You can also just hit this little indicator here, and this is going to open up the asset in one of our blockchain explorers called Algo Explorer. Again, this one here is a really great tool. There's a few explorers as well. This particular one also has a API service that you can utilize to access information on the blockchain. This is by Rand Labs, and this comes up with the actual asset that we just created. And so here's the transaction ID, for example. You can click on that, and this will go ahead and bring up the transaction overview. So there you can see the myurl.com site. You can see the number of units, number of decimals, everything that we had just specified. And then also there is a note field too that you can, is free form there. So that's pretty much a quick demo on that. And then the other Explorer, there's actually a few of them now. This is Goal Seeker. This is another one that's available. It does support multiple networks. So you can see this is mainnet, and you can see the exchange rate of the algo. The algo is the native cryptocurrency that's on the Algorand blockchain. And then also you have testnet available too. So that's kind of the lay of the land in terms of a few of the tools. There's one more I'm going to show, which is Algo Signer. This is actually something that comes through in the Chrome store as an add-in. So you can just look up and go out to the Chrome web store. It's an extension. And what this provides is the capability to sign transactions. So what I could do here is you can see I've got an account. In fact, let's go back and just grab this creator account here. Like, for example, we'll copy this off. All right, I'm going to go back to Algo Signer here, and I'm going to log in. And then once you can see it, you've got testnet support, mainnet support, and this will get imported from the Algorand wallet, which is an app you can download from iOS or Android. And what I'm going to do is just click on this, and I'm going to send some testnet algos to another address. So that'll be the one we just created. And then I'm going to send like one of these there, and this will be like my note. And I'm going to add to it, and we're going to send that, hit the password. And then what we'll see is the transaction, right, that comes up, and you can just copy that off. Again, go out into one of the explorers, and you can actually see that information on that particular transaction, all pretty much instantaneously. You see how very, very robust this is and how quick this is. This is a big difference, from other types of blockchains that require mining, and they require a very slower kind of approach to building blocks on the blockchain. I'm going to pause here for a second. I'm going to talk more about that last thought in the next section here. But Ryan, I'm going to ask you if there's anything worth sharing here in the way of questions, everybody.
We had one question that came in that had to do with the blockchain interoperability. It was a very deep question about how do we make some connections to full-arm blockchains. Talked a little bit about the hash time lock contract as the standard way to do that, and if the foreign chain is also a smart contracting platform that we can have additional features built onto those chains for watching what's happening on both of those chains and being able to facilitate the inter-blockchain communication. That's all we have at this time, Russ.
Oh, okay. All right. That's great. Well, thanks, Ryan. I appreciate it. And keep those questions coming in. We got Ryan up nice and early too this morning to go ahead and answer these questions over here at the East Coast. So take advantage, and we'll go ahead and continue here. We'll get to more meaty things in terms of developer type scenarios. So we're going to talk about layer one features. So what's layer one? Layer one is built in right on the blockchain. It's part of the protocol. So there's no additional software needed. This stuff just works right on the blockchain, just like algo currency is available on the blockchain. So what we see is a the different sections we're going to cover here are the Algorand standard assets. I kind of gave you a preview of that visually, how you create one of those. We'll also take a look at atomic transactions, which are very useful for tying a lot of technologies together, as well as smart contracts that Ryan touched upon, and something called rekeying. We'll talk about those features. So it's important to get a base set of information about these core features, because you can utilize these and really quite significantly in the solutions that you're building on blockchain. So let's talk about the protocol. So the Algorand blockchain pure proof of stake protocol is what we use, and it really provides true scalability. And this was created in parts by Sylvia Macaulay, who's the founder of Algorand. He's also a Turing Award winner, and he figured it out. In the consensus model, you don't need everyone to participate in the consensus. What you need is a representative sample, and you do that with math. And specifically, we have the verifiable random function that does that. And by the way, that is open source, as well as the source code for the Algorand blockchain. So it is available and transparent there in that respect. The true scalability part, very, very important, scaling to billions of users. It's amazing how this scales. Then you take a look at the infrastructure longevity. We've had multiple rollouts already of protocol updates. In fact, all those layer 1 features I talked about were actually in Algorand 2.0, right, that we came up with a few months back. And so we got a really good update methodology involved with no downtime, so that's a very important thing. Technical flexibility, same way, built right in, a lot of SDKs available. Transaction certainty. This is really important, and this gets down to really the approval process when blocks are written to the blockchain. There is no forking, unlike some other blockchains. Everything gets written pretty much instantaneously. The blocks are created in under 5 seconds, is what we've been seeing on our throughput. And that really lends itself quite nicely to point of sale type transactions, as well as really most types of transactions that are needed from a business solution standpoint. Also extensible platform capabilities. We got REST APIs as well as the SDKs, and very energy efficient. You can actually run a node in a Algorand blockchain on a Raspberry Pi. I mean, that's how lean and mean it is, and from an energy standpoint. Unlike mining and other blockchains that require very expensive equipment, is not green at all to generate the blocks. Very cost efficient. Transactions are under a penny. 0.001 algos, I think, is traditionally what the cost is for doing transactions. And then really true security, and this lends itself to the nature of blockchain. I had a cybersecurity expert in one of my seminars. I did a seminar for Women Who Code over here in Tampa, Florida, and Brenda was in the class. She's a cybersecurity expert, and she tried to explain to the entire class there really how secure blockchain is, and the fact that many of you are familiar with two-factor authentication, right? So you have a sign-in process, and then it goes to something personal like your device or your email to verify afterwards. Well, it's very similar to that, but you multiply that times the number of blocks in the blockchain, and we're like in millions. So, and the reason that is so secure now, I think you can get the picture, because it's tamper-proof. You can detect tampering very, very easily in the blockchain. So security baked right in, things like audit trails built right in. And so this is really the pure proof of stake protocol in its entirety here. So more specifically, diving down into the features, you have Algorand standard assets, which creates native tokens. And the native tokens could be, like you saw me do a Rust coin, right? And this is an example of that particular site that we just looked at here on the right. You have many functions, including administrator functions, as well as asset spam protection. You can't just blindly distribute these tokens to anybody. The person receiving it must opt in order to receive those particular tokens. That's a very nice feature. Um, the administrative functions, you can have control of managing the account, who's in, you can have folks that are in charge of freezing, reserving, and clawback. You can see all those here on the right. Those could be identified by different accounts or handled by different accounts. So it does reside on layer 1. And then examples of assets include fungible tokens, which are all the same in value. So at the same time, so like in-game points or stable coins are examples of that. Loyalty points, system credits, cryptocurrencies, fall into that category as well. And you have restricted fungible tokens, including securities and government issued fiat. And that would also entail the ability to do things like clawback if needed. And then we get to non-fungible tokens is another scenario. And the way you create a non-fungible token is you create a quantity of one. And this is the case for many different types of scenarios as well. Great for supply chain. When you're trying to monitor, say, drug manufacturing from the facility out to the user, there's several steps along the way in a supply chain. And traditionally, this has been done with paper sign off or maybe programmatic sign off with a centralized data authority. But really, it gets a lot easier with a blockchain where you have this. First of all, it's globally accessible. B, you can write to this chain and update it, and it would be many players could be involved in part of this process. It doesn't have to be one entity or organization. It could also go to do real estate and same type of thing. Between non-fungible and fungible, the real estate stands out to me as a way of differentiating them, where you see maybe a 4-bedroom house with 2 garages in one locale, and the same house, exact house, in another locale, and they're worth different amounts, right? So they're the same, but they're different. They're unique. Each one is unique. So that's the best way to kind of describe that. Identity purposes, certifications, collectibles, and then restricted tokens as well. Yeah, and I see a question about identity management. I think one thing is not done right on the blockchain is identity management. You as a developer would be responsible for that identity management as part of a solution that you would build, and that would be off-chain, and that would be, in essence, a layer 2 type solution that would integrate with the blockchain. Okay, so then those are some our examples, kind of give you what assets can be used for, and then we get to atomic transfers. And the atomic transfers, what we see here is it's kind of very, very similar for those that are familiar with, say, SQL Server. It's a transaction on SQL Server where you can have multiple tasks wrapped up into one, and either all succeed or they don't. And so here we can see what we're trying to do is send algos from person A to person B, and then also from person B, we want to send the concert ticket to person A. So this transaction doesn't complete if the first person A, does not provide the algos to buy it, and then B, it's not complete unless that concert ticket is delivered. So this really facilitates, lack of trust among players, and it does facilitate a great way to do this. So it's an on-chain native function, easy and secure, and up to 16 transactions can be done within an atomic transfer. This guarantees exchange of goods is the bottom line. As part of this process, you could have one of those transactions be a smart contract. You can have one of those transactions be an asset related transaction. You can have one of those be a regular algo transfer of funds. And you can wrap all of those up into one atomic transfer so that they all complete successfully or not. And that's a very good point to make, is that these technologies you can combine together really to create yourself a killer solution. So there you go, combine it with other Algorand technologies. Examples of atomic transfers, it might be this: simplified, expedited settlements, maybe efficient matched funding. You also have, reduced counterparty risk and enable any multilateral trade. Circular trade, certainly possible. Group payments combined with any Algorand, ASA, or smart contract. And then instant settlement for complex multi-party asset transactions. So distributed payments facilitated as well. Now we get to smart contracts, and let's take a look at the architecture. So I know we had a question in the queue about this. This will explain transaction approval language. That stands for TEAL. It's Python. There's a Python enabled compiler called PyTeal. So that'll generate from Python code the TEAL. There are two types of smart contracts. One is the stateless for approved spending transactions, and stateful, which does provide global storage to the entire blockchain, as well as local storage on an account by account basis. You can combine, once again, with other Algorand technologies, atomic transfers, Algorand assets, and you can even combine stateless and stateful contracts together. And I got demos showing this all together. These are all accessible from the SDKs and in Python and Java, JavaScript, and Go, and C#. So smart contract values, basically in the financial industry, these come in big for things like trade finance or clearing and settlement, or financial data recording, as well as digital identity. Then in DeFi, you see you got escrow accounts that could be facilitated payments and credit and lending, as well as stable coins. So this is a big impact in terms of what the value that smart contracts bring to the table. This brings us to Algorand accounts. What are the types of accounts that you can have on Algorand? Well, we start out with the standard account. This provides a cryptographic key pair. One is a public key and the other is a private key. And again, for those brand new to blockchain that are here online, the public key is the one you want to give out to everybody. You don't have any restrictions whatsoever, because that's what's used for people to send you money, right? You want to be able to get money, right? Get algos or get assets. The private key, on the other hand, that's used for you to do transactions with and spend, often referred to as a spending key, is the private key. And you have to sign off on that in order to send something from your account. So that's the pair key. That's the key, especially you want to guard very safely. Things like the Nano Ledger, for example, is a little device that looks like a USB, and it allows you to store your cryptographic key pair in there safely and access it through Bluetooth when you need it. So very good device. Then we get to a multi-signature account. A multi-signature account in the middle is all about a threshold. For example, sometimes you receive a check and it requires 2 signatures in order for you to cash it. Well, that threshold is 2 people. They have to sign off on it. So let's say I've got a multi-signature account of 3 and I set the threshold to 2. Again, it means the same thing. 2 out of those 3 have to approve the transaction. And then once that occurs, then the funds can be distributed from that multi-sig account. Very useful, if you have multiple parties that have a vested interest in a particular asset, and you want to make sure that you have a certain number of them signing off on that before it goes and be sent. Then you get to the logic account. This is guided through smart contracts. So a program can sign off on an account, and the way it does that is if the program returns true, you're good to go. It signs it. If it returns false, it does not sign the contract, and the contract will not work. So those are the 3 types. And the reason I bring that up, because there's a new feature now called rekeying that's available. And this really solves a problem that we've had in the past, which is you create an account and you get a public key and a private key, which we talked about. And what happens when you want to take this key pair and say modify it? Maybe I'm growing and I've started out with a single account here on the left, but I want to go to maybe a multi-signature account to do the signing. Well, up until now, you've had to create a new pair, and it was very cumbersome to do that. And what we can do now is we separate basically the private and public keys and assign others authorized addresses to approved transactions. So this is a very cool thing. And you can see what we do there up on top in the right in the green box. On the transaction record, there's actually another field now called authorized address, and the authorized has rekeying support. Also, the Algorand wallet does provide the ability to flip between testnet and mainnet accounts, so developers can use that for testing as well now. And then you see the cryptographic key pair in the middle gets separated, and then you can replace that either with a multi-signature account or another account or a a logic account as well. So those are all available, and transactions are authorized then by the signing address. No other blockchain offers this way to change private spending keys so easily. Now let's take a look at a scenario that we're developing here with combining layer 1 features and voting. We have voting commission that is going to issue, so for example, this is a voting kind of solution scenario. Well, what we're going to do is we're going to atomically group this entire thing here. We're going to go ahead and then spend our voting token. Then that is going to say vote for candidate A with a voting smart contract that says that does all the legwork to make sure that this is legit. They have the token, or you can think of that, maybe they have the funds, in another type of scenario, also that they haven't voted already or double voting, and then you increment the candidate vote total, and that goes into global state on the blockchain. So there's no second guessing there. Now, what we see here is layer 1 crowd funding example. So same type of thing. We have a crowdfunding escrow account, which is a stateless smart contract that's going to return true or false, and that's going to do a payment from escrow to user 1. Now we're going to atomically group this whole scenario as well. So we see that we take that and we're going to go ahead and say, okay, user 1 claims the escrow funds. Now that's going to be a stateful smart contract, really to make sure that there's enough funds in there, and that that state is maintained on the network as to how much has been raised to this point. And if enough has been raised, then you go ahead and complete the transaction. Otherwise, this transaction will fail, and then everything gets returned back to the investors that want to invest in it if you haven't met your goal. So that is a very, very common type scenario. All right, Ryan, I'm going to just ping you real quick and see how we got the questions going, and if there's anything you'd like to share with everybody here verbally.
We've had as we've been going through here, but nothing is needing answering right now. The questions have been a little bit more about interoperability, a little bit about what does the development environment look like, and some questions about going a little bit deeper into teal. So you've been doing a nice job of covering off on those thus far. So let's talk about developers.
Yeah, developers. I don't know if anybody remembers that that video from Steve Ballmer at Microsoft. I used to work for Microsoft for about a dozen years, and I was actually in the audience live when he did that. I mean, it was a Microsoft kind of a company meeting between sales and the tech folks. And honestly, I was standing on the top of my seat, cheering and chanting with Steve Ballmer, going, developers, because, at that point, Microsoft really realized that developers was really the most important thing that they had going. They had to get developers on board to build all these great solutions that used Microsoft products. And many software companies are in that same boat, including Algorand. We really need solutions that are built. And so developers are extremely, extremely important to us. And I'm so happy we had such a great turnout. So the things we're going to go ahead and cover here. First of all, I'll give you the lay of the land in terms of the type of networks that Algorand has. We have 3 main networks: the BetaNet, which is used primarily for protocol, new features, to test the waters. We also have the current protocol version in both testnet and in mainnet. Testnet mirrors the protocol or software that's used in both of those environments. And the idea there is if it works in testnet, it's going to work in mainnet. So the thing to be, be aware of is each of these environments could have the same physical account address associated with transactions or whatever, but that account balance would be different. So BetaNet is a different environment than testnet. Testnet is a different environment than mainnet. So in testnet, I may have thousands of algos, and in mainnet, I may only have 5 algos for that same account. So that is something to be aware of, especially when you're working with private networks too, because private networks then, the way I like to consider that is not really from a security standpoint. You think, oh, private means security. It really means it's local, it's personal. It's a personal network right on your own machine that you can develop. And the protocol that you can use, you can start with the protocol from BetaNet or from testnet or from mainnet and use that going forward. So it gives you a very nice environment, stable environment to do your testing. I myself used a private network a lot when we have a rollout for BetaNet, and the BetaNet typically will fluctuate a lot in release updates right before it goes live over to testnet. So it's not quite what you call a stable environment. So what I like to do is create a BetaNet, private network based off of that BetaNet. And now, no matter what happens to BetaNet, I've got my own kind of copy of it, and I could go ahead and develop and test my heart's content in a consistent manner. Another new capability of private networks is more in terms of the sandbox I'm going to talk about. Is the sandbox defaults now to a private network, but also includes access to something called the indexer, which will allow you to do queries. So there's becoming more and more of a use case now for private networks going forward, and we'll actually show you that some of the in the demos coming up. So let's take a look first at the developer portal, and we'll just bring this up over here. This is the developer portal, developer.algorand.org. Oh, look at that. My recent tutorial just popped up here on the banner there. That was the one that reads and write to the note field in, I think it was JavaScript or Python. And we also have Chinese available as a language now on the drop down over there. So that's very new. So we're getting to be globally. That was brand new right off of there. But the thing you want to go to is the Start Building tab. And what that does is it brings you to the documentation right here up on top. So the getting started, this is information to set up your node, your workspace, and then your first transaction, which I'll show you in a minute. But here you can see an example where we've got multiple languages like Python, Java, Go, all supported here, and you got code snippets for each. And then typically all of this code is referenced and available to a link either at the start or the end of most of these in our examples GitHub repository. And you want to go to V2, that's the current version, and then you can see all the different ones for Python, so and the other languages, and you can see the samples right there. So that's a great place to go ahead and get your information. Okay, let's go back over here. So we can create your own nodes. We'll talk about node setup here, which was really the first step, and you can do this either on a Mac, Ubuntu, other Linux distros as well. For example, on a Raspberry Pi. I did see a recent pull request come through to do this on a Windows environment as well. And then used to take several hours as well, but now there is another fast catch-up feature that was recently introduced, and rather than taking days to sync the entire blockchain, it takes minutes. So in about 5 or 6 minutes, you'll have a node ready to go. Sometimes it makes sense to do that. Sometimes it doesn't. And for example, if I have a mobile app, I don't necessarily have localhost available to me in an iOS or Android app on the user's device. So I need to point elsewhere to a node to access services. And there are some companies out there that provide these API services. In other words, they have a farm of indexed archived nodes, and you can access from these nodes from SDK code on platforms that do not have nodes. So you don't have to run a node. You can use one of these services. And the third choice here is using Sandbox. And that is very easy to set up. And that is really the recommended approach for developers, and involves two steps. One is creating a Docker instance. And then the second thing is it can be used really for any environment. It's really not meant for production like mainnet, although you could start up with mainnet. And it really is a minimal sync time. Again, just a few minutes and you're up and running. The thing to note here though with Sandbox, when you bring it down or when you clean it, actually be more specific, everything gets reset back to the way it was. And that's why really not for production use, because if you're doing any transactions or anything like that in that particular Sandbox environment, that you have to really be very, very careful. So that is for the most part used in BetaNet, testnet, and then now private network. So with Sandbox 2.0 recently released, you basically install Docker and then clone the Sandbox. That's it. On Windows, I think you might have to install Ubuntu, but it does run on all the environments. This now defaults to the private network. For testnet, you would have to actually put in a parameter, Sandbox up testnet. If you drop off testnet, you just get the private network. And again, all the networks are supported. And Ryan actually did a developer office hours, which we do each week. On YouTube, we posted it up about the Sandbox, so you can take a look at that as well as more. I will provide a link to this deck at the end of the session as well. And this is what the Sandbox looks like. You actually have the host coming up with, these are the addresses that you would use for each of these daemons. So you have the algo D. You'd be using localhost 4001. The token you would use in your application would be all A's. And then KMD is our kind of an online wallet type approach, really useful for kind of wallet testing, but not really useful for, I would say, for production applications. And then Indexer is the query facility that now brings you right off the bat in the private network. You start up with testnet, you'll need to have your own Indexer index. And I have a section on Indexer coming up. And really, the only thing to show you here on the Sandbox is basically this. You have this environment now ready to go, and we do have tools that are command line tools as well. For example, goal, node, status, and then hit enter, and then now it'll go ahead and give you the status and which network you're connected to. You can see at the bottom of the screen there, I'm connected to testnet. No sync time, that's very important. If you see sync times, that means, and you're having problems with your transactions, that's why you're having problems with your transactions when you're developing, because you got to be synced up in order to do that. Okay, so let's go and take a look at next thing here. And I talked a little bit about this when we took a live look at the developer.algorand.org site. Basically, that's your step-by-step approach to getting going. And let's talk about the SDKs a little bit. I alluded to the fact that we do have support for Go, Python, JavaScript, and Go. Or I missed one of those when I was rattling them off: Java, JavaScript, Python, and Go. And then you can see you can create standalone functions, as well as create accounts, count mnemonics, create transactions, sign transactions, and broadcast to the network. And then you also have a community SDK, which is really great for C# developers out there. I actually built a C# solution that was a cross-platform solution for Android, iOS, using in Windows using C# and Xamarin libraries, because the library is compliant to the .NET Standard 2.0, so you can do things like that. And this has been updated recently to the version 2 API, so this is all up to date. You have all the capabilities, including stateful smart contracts available to you with that particular SDK. So this is a great, he did a great job on this in the community. Riley did. All right, the way you get going, there's a great link up there in the Reference SDK migration is to install the SDK within and how to instantiate it. So here you can see on the right, the install part. So for example, if you go down to the JavaScript section on that page, what you can see is the ability, how to install it. And then it shows you, how to instantiate it right there. So that then the link there. Well, I didn't mention this before, but if you are developing in BetaNet or testnet, there are corresponding dispensers to give you dispense algos to your account so you can do your testing. You will need algos in the accounts because there's going to be transaction fees associated with the transaction that you deliver. So the first time you go to work with Algorand, you might get an insufficient funds, error message, and that's what that's about. It hasn't been, maybe you created a new account, but you didn't dispense funds to it. With, forgot to mention, with Sandbox, now the default is private net, I mentioned, but it does also create 3 funded accounts. So those are already funded. And what you would need to do is use those as your dispensers, and you can write transactions or create SDK calls or goal commands to transfer funds from those any of those accounts to any new accounts as you might create in your private network environment. All right, demo time, some code. Let's get into the code. We're going to create accounts. We're going to show you the dispenser, and we're going to do our first transaction. And we had a good number of Java developers, so we're going to start out with Java. We're going to be an equal opportunity employer, show you all the languages here today. So what I'm going to do is bring up this first piece of code here in Java. And I am going to, I already got my breakpoint, and we're just going to create some accounts here to get going. And what we'll do is we'll see the account start to spit out down below right here and the corresponding passphrases. So you basically would want to copy all of this off and then use these later on and restore your accounts from those passphrases when you're developing. And what's the one thing you need to do here? Well, we need to fund these, right? So we go out to our funding site, and we will go ahead and dispense some funds. So let's go ahead and do that. And so this is the testnet dispenser, and that's how it works. You just paste that account in there, you get a success code, and then you can look up that transaction. You can see you've got 100 algos that have been dispensed to that account. So that's pretty straightforward. And then in terms of your first transaction, this is going to be the lay of the land. So what we can see here is we've got the ability to set up to a node. And this is the first step right here that you saw these values in my sandbox that I am utilizing. So I'm going to go ahead and run this. And then when I hit this breakpoint, what you'll see here is that I've got the instantiation here in Java of the client. So this is our client, LOD client, that we're going to pass in that address and then that token and port number. Then let's get down to the actual meat of it here. So you can see here I restored my account. This is going to be the sending account or the signing account, and that's the passphrase. And this is how you restore that account from that private key. Again, not recommended to do this in code in production apps for sure, but this is great and very handy to do for demos and for when you're learning and testing your own code. And then you can see here I've got the hello world is going to go out to my note. This is going to be the receiving address, but here's the meat of it. So this is the parameters that we get pulled back. This gives you your round range and things like that that get passed in as an argument here in the transaction, but it's pay payment transaction builder is what we're doing. So we got the sender address, we got the note field, we got the amount, we got the receiver. That's it. Boom. We just go ahead and run that. Now what's going to happen is we're going to wait for this confirmation to occur by calling this. So this waits for it to get written to the blockchain. Once I get past that, it's already been confirmed in there, because it'll wait there for, you know, up to 5 seconds or so to see if it actually got written out, which is very useful, because sometimes you do want to make sure it's written out before you proceed with any other transactions or anything like that. And then there is a pending transaction information. I just pull in the ID that I got back from sending the raw transaction, and this is the command here that broadcasts it to the network. So again, to kind of recap, you instantiate your client first, which you did up on top. Then you do the transaction. Then you do the broadcast. Then you wait for that to get written to the blockchain, and then you're good to go. So now I'm just going to let this run through its fruition. You can see the printouts down below. So this is the transaction information that just got written to the blockchain. You can see the fee that was done, the amount that was sent over, and this doesn't have any local state or global state yet. We have other demos where we're going to deal with that. So that's the basics, 1, 2, 3 on doing your first transaction. Let's continue on now with doing more transactions through multi-sig and atomic transfer. So, and yeah, the code is available online again on that features, and I got a link on at the end of the slide that shows that. So let's go over this time. We're going to be going to not that one. I'm going to go to my Python here. So first thing we're going to do a Python example here now, and this is going to be the multi-sig transaction. So let me go ahead and fire this up, and we'll go ahead and stop in our desired spots. And what we've done here is we're going to do a multi-sig example. So we have 3 accounts that we've restored up here. And again, there's that wait for confirmation routine that we have up at the top. But the way this works with multi-sig is basically you have the threshold that you just define and how many signatures are necessary. This is the makeup of the multi-sig. So you have the version, the threshold, and then which accounts that you want to have in there. And so in this case, I'm saying both accounts have to sign off. I have 3 accounts available in this application, right, that I've restored up here. So we're going to transfer basically funds to account 3 is upon successful signing on both of those accounts for the multi-sig address. This multi-sig address, when I pop over it, I print out down below, and this is the guy that you would have to copy and go paste into the dispenser, make sure it has funds to dispense, because that's where the funds are going to be coming from, is that multi-sig account. So now we do the same thing again with the address and token. And then this is what the payment transaction looks like in Python, very similar, right? In terms of functionality in each of the SDKs. You've got the sender, you've got the, which is going to be the multi-sig address in this account. In the case, you have the parameters, the recipient, the amount. And then what we do down below here is we have this payment ready to go. And we're going to do a multi-sig transaction with that particular transaction using this multi-sig account. And this is where the signing comes into play. So we're going to sign off with the private key from account 1 and account 2. Once that's done, then we can go ahead and successfully do a send raw transaction. And when you're sending a raw transaction or broadcasting to the network, that is typically where you would see errors. It'd be on that step if you have any. Things like insufficient funds or double spending or things of that nature, or maybe you didn't have appropriate sign off, or if it's a smart contract, it didn't come back true. So and you would see that in your error processing what that is. But it was successfully sent. You can see see down below. So it was actually signed off by both of those accounts in multi-sig. And then atomic transfers. Let's take a look here, atomic transfers. And what we can see here is the ability to do basically two things at once. And I'm just going to go ahead and run this, and we'll explain this at the breakpoints in the code. So this is the deal here. What we want to do is we want to go from account 1 to account 3. We're going to send this amount of 1 algo. These are microalgos, so it's 1.00000 microalgos. And so it's 1 algo and 1 million microalgos. Then what we have is the transaction where we also want to send an amount from account 2 to account 1. And we want neither of these to happen unless both of them does. And so this one, we're going to send 2 algos. And once that happens, then we come down to the magic secret sauce here that combines these into a group ID or grouping transaction. So now you can see we've got the 2 transactions we're attempting to do, transaction 1 and transaction 2 that we just called out up above. There's transaction 1 and transaction 2. And then we're going to get a group ID that's associated with that, and then set the group property on each one of those transactions to that group ID. Kind of makes sense. Then we're going to assemble those together in a signing group, appending those into the signing group, and send that transaction and broadcast it to the network. And now it is. So now we have a confirmed transaction down below. You can see the where the transaction information that was confirmed in the round. You can see that right down below, and you can see both of those transactions, right? You can see the 1 algo sent on the first one, and then the 2 algos on the second one. So both confirmed in that same round. And life is good, right? That's how you go about doing that transaction. Ryan, I think I'm going to pause here for a second and just see if there's anything you want to share with everybody before I continue on with the next section of the presentation.
Sure. Well, I think there are some questions that have to do with building smart contracts. Specifically, there's one about an interesting use case about real estate. And I think that you're going to cover some of this once you get into smart contracts and combining a lot of these different technologies together. Like in the real estate example, we talked a little bit about using the Algorand standard assets, the ASAs, for creating KYC tokens, land records, different steps within that workflow, and then being able to attest to who has signed off, which party has signed off on those as they're going through that. All that's going to be stored inside of that, inside of the state of that smart contract application. So I know we'll get to see some of that when you get into the application section here going forward.
All right, great. And let's go ahead and continue. Thanks, Ryan. Appreciate it, man.
You're welcome.
All right, let's go ahead and continue on with our great demos here that we've got lined up for you and bring this session home. We're about, looks like 2/3 the way through. We're looking really great on the time. So let's go ahead and continue here and talk about some really great stuff here in the way of contracts. And so the first piece we're going to cover here is the Algorand stateless smart contract. So this replaces the signing of transactions like we talked about before. It's a logic account, right? And any transaction sent from this account will be verified by the predefined logic. This is great for use with escrow style accounts, split payments, hash time lock contracts as well. The logic signature is really any transaction signed with the signature will be verified by the predefined logic, or in other words, a delegated authority. And this is good for recurring payments. So the main difference between these two, a logic account and a logic signature, is in a logic account, you just have the smart contract determining whether it's yay or nay, it's true or false. With a logic signature, not only does it have to return true, but it also has to be signed off by a delegated authority or another account as well. So it combines those two things. Sometimes you need a safety guard, right, to do that, or another authority, right, to go ahead and do that payment. And an example would be recurring payments. So maybe, and I'm going to show you this in the code too as well in the next demo. So let's go ahead and do that and show you the contract account. So let's go to our orphan child in the way of development languages. Let's go to Go, and I'm not, maybe orphan child was a bad choice of words there, but least popular language, according to the voting that we had at the beginning of the language, this question in this scenario. But, and really the purpose of this is you can see that really all the SDKs, no matter what language you are using, are very similar in operation to what I'm showing you. So you may not know the exact syntax I am showing you, but, you can use your Rod Serling imitation picture, if you will. It's in your favorite language. I'm showing you these demos. So here we're going to just open a sample teal program. And this teal program is basically, it's a stack language, right, for teal, and it pops values off the stack, and there's one value on there at a time. And this is only like 4 statements long. We have an argument we're passing in, and we're going to compare that argument to see if it's equal to the value of 1, 2, 3. And if it does come back as, it will come back as true, and that's exactly what I have in this this file that I'm going to go ahead and open up. So then I'm going to use a teal compiler. So the teal compiler will take that raw file, right, that I read in, and then go ahead and create a response that's going to be compiled. Because a lot of times you need a byte array to pass in as a parameter. This is how you get those suggested params that we have. And we come back now to actually do the make payment method that you've seen in the other examples. Once again, we have the address, the receiver, you've got valid rounds, you've got the Genesis hash, and then we go ahead and continue here. And what we'll see is the transaction then is signed with that LSIG and the transaction, and it will go ahead and complete. Down here below is what you can see. It has been indeed confirmed. And really the other one would just have an additional step in here where you had a sign account that you would actually add to do that. And that would be available too as well in your repository of source code that we're going to share with you at the end. All right, so let's go back over to the deck and kind of give you the lay of the land for stateful smart contracts. And here's a life cycle you can go through. You would create an application. You can opt in and participate in local storage. And then you call the app. And so that will execute the application. And if you want to provide an update, you can certainly do that and update the application with that update method. You have the ability to delete the application if you wish. And close out, we'll go ahead and, close that particular contract out. And clear state will always clear. So that's the difference between clear state and closeout. Closeout, the teal logic must be true in order to close out. If you always want to force a clear out, you can just use clear state, and that'll be, and there's some scenarios you need to know that for. And we have this all available on the lifecycle page on our documentation, which I have listed on the slide as well. Let's talk about the Python teal library, or PyTeal. Basically, the way this works is you have your code in Python, which many of you are familiar with. And this is a great way to ramp up to do smart contracts, is using PyTeal, because this is going to, when I compile teal, like I showed you in the application, it's going to go ahead and generate this code that gets compiled. So we have a really good thing here, right? So now it's easy to develop in a higher level language, the stack language that we have for PyTeal. And it makes sense to have something like a stack-based language on the blockchain, because it doesn't require a VM. It's very lightweight and it's lean and mean. And you definitely want all 3 of those things, right? When you are working with a blockchain, you don't want something that's heavy, that takes a lot of time, because that affects everybody. So when you create a new application, this is the process, right? You create the PyTeal, then you use the compile teal method with the mode set to application. And then what you can do is you can actually compile that source that's going to be used, and that's a SDK function that you can use to create what's needed for a parameter that is called for the application smart contract. So here you can see a application create command where we're passing in the compiled version from this compiled teal source. So that is kind of the sequence that we use here. Now let's talk about debugging, because we're just saying how you debug one of these as well. You know, typically you want to debug three things here: the accounts, the signed transaction, and the approval program source. So what we do is have the facility combine all three of these into what we call a dry run request. So that's going to, in other words, package up all that information that we need to go into the debugger. Then you do the debugging with teal debug, and there's a teal debug command line utility, and I have it actually invocable from my SDK code I'm going to show you that will instantiate a Chrome inspect instance that you can go through Chrome and debug that. And so there you can see the kind of what that looks like down below that gets passed into the teal debugger. And this is the Chrome inspect. What this looks like, we'll show you this live as well. So if you go out to Chrome and inspect, then you will see this in action. So on the right, you would click inspect there, and then it would bring you up into this IDE for, you know, stepping through with the debugger with breakpoints and stepping into code, overcode, that sort of thing. So let's take a look at this complete cycle from end to end. Let me go ahead and bring that back up. And run this Python example. And I gotta close my blinds because I'm getting a blinded sunspot in my eyes. Oof, that's better. I got all these green spots in my face here. Okay, here we go. So I'm just going to go on to the main line here and show you the breakpoints that I have set first, and this mirrors the life cycle that we talked about. So I've got three programs in here. I've got an initial program. I've got one I'm going to update to, and then this one here is just a clear program that is very simple, and I'll show you the code on these when we go through it. We're going to compile all three of those. Now I've got my compiled program code available for use, and then I'm going to create the app. I'm going to opt into the app with both. I have two accounts, a user private key and a creator private key. I'm going to do it for both. And then this one here, call app, is the one I set a breakpoint into for the debugger. And so at first, we're going to send in the original program source and run it. And then we're going to see that this updates global state. The only difference I have between the original program and the update is the update has the ability to increment a local counter as well as a global one. So the global one is the only one that's going to be first, and then we're going to come through and update that app with the new code, that additional code that also updates not only the global counter, but the local counter for that particular account. And then we're going to call that again with the refactored program, the new one, and hit that same breakpoint, and you'll see the additional code come in. And then I'm going to simply show you that local state, and then we'll do a delete app and clear the app at the end. So that's the life cycle. So let's go and run this. And so the first thing you want to do is declare your application state storage. You can see here that I'm going to define the number of ints and the number of bytes. Those are your two data types that you have accessible to you on the storage. And then also I'm going to say this contract is going to use 1 int for global and 1 int for local. I'm not going to use local bytes in either scenario. And then that will create your global and local schemas with the state schema API command. So here's the two accounts I'm going to be using. And then I'm going to get down to create the initial, so this is PyTeal, right, that I have here that's going to generate the code. You can see all I'm doing is I'm going to put globally a counter together called with this counter, it's going to increment that. And then the next one I have is the refactored one, which also then has this line, which is going to put the local counter. And then the clear state is very simple. It's 1, right? So that's going to return and do that. So now I'm going to compile that. And I'm going to do that 3 times, 1 for each. And now I'm at the line where I'm going to go ahead and create the application. So this is the method that will create the application in this routine, this application create TX. And I could make this display a little bit bigger down here. So once this transaction comes back, this will hit our next breakpoint, which is going to say, okay, we're going to opt in with both of these keys. And there's the opt-in command. Again, the sender, the params, the index now that you've created. So the index was returned back here as the value of the ID right down there. That 1328371 here is the app ID that we got back from the first transaction. So this will go ahead, and it all uses the same process we've seen before. You sign it, you send it, you wait for the confirmation. And so now that is good. And now we're going to do the second one, and that'll go ahead and opt in for the both accounts are ready to go. Now it's the rubber meets the road. We're going to call the app and with the first approval program. And here we are going to indicate, okay, we've got this ready to go, and I've got this STD. I'm going to execute this teal debugger command. So let's go back out to the browser. It's waiting for me over here in the Chrome Inspect, right over here. All right, so I'll go ahead and inspect, and now this will bring up the browser with our code to go through. So this is the teal code that got generated. It's basically going to take the global get, and then we're going to do a put, and that's going to update the counter. And on the right, you can see areas where you have the counters defined, and you can see it's currently at 3. We're going to step over this, and then you'll see that counter in the global section then turn to 4 once I put it right there. So now you've got 4 going in the counter, and then we're just going to return that back to the application. So let me go ahead and close this window up, come back into the code, we hit our next breakpoint, and then you can see we're going to go ahead and send that transaction through and then wait for the confirmation. So that's a very useful thing to know how to do, is to do the debugger. And then we're going to pull the global state value counter out, and there you can see the value of 4 that came back like we saw in the example above. All right. Next step is we are going to update the app. And now this time we're going to update it with the update program that also talks through the logic, the local program. And so we're going to do the same thing. We're going to do this application update. And that's been done. And then once that's done, we're going to call the application. And let's go back out to the inspection here. Inspect here, and now you can see that the code has been added for the local counter after the stuff with the global counter. And once again, we will go ahead and get this out, and you can see here we've got these other objects we're going to expand as well. And you can see here I'm going to step over these and go right down. You can set breakpoints here too if you want to hit in the margin, hit a breakpoint and go through it. And now I'm going to take that local counter, I'm going to initialize it. Now we're going to put it out to the local account. So now this is available on this local account. And you can see the local counter that came out down below for the application. So run this through, come back and go ahead and send that transaction, wait for the confirmation. Then the last 2 steps or 3 steps will be to print off that value that we saw in the counter in the global state is going to be up by 1, but then there is the local state coming back as 1 as well. Then we're going to delete the application. That's the delete function. And then coming back, then what we want to do is also it'll delete it on the creator account. And what we also want to do then is clear the state on the user account, and that will be the last one. There it is, clear state function. Now, there you have it, folks. The complete life cycle of a smart contract, and the crowd goes wild. Yay on that demo. All right, so let's go ahead and go back now out to the deck. We'll have a few more things here. We'll go ahead and show you on Indexer, and then we're going to wrap up. So Indexer is a great service, a great query tool. Up until Indexer, the Indexer, that technology that came out, you had to search the blockchain. So what if you're writing a game and you want to create a leaderboard? So you want to say, and you're giving out tokens in your game, and you want to do a leaderboard of the top 10, asset holders. Well, you would have had to search the blockchain entirely, and that's millions of blocks to do that. And the performance, as you can imagine, would take a while to do that. And what we've done is simply feed off of that AlgoD process and populate a PostgreSQL database, which is made for doing queries. And so what we could see here is this is going to populate this database then that you would be doing your queries against, basically. So how do you do this? Well, you can build your own node. I've done that as well. And this will take about 3 or 4 days to actually fully populate. You need to have archive and indexer config properties turned on, which I do not believe is the default. So that you would need to create, check your config file when you go to do that. You cannot use the fast catch-up feature either for that. You have to really just wait it out and get 3 days worth. It's going to be very big. It's going to be about 130 gig right now is the total size of that. So those are the things. If none of those appeal to you, you have a couple more options. One is you can utilize a service that already has those indexers built. Again, this would be through PureStake or RAN Labs. And now a third new option is the Sandbox default for the private network includes an indexer index. So that is beautiful. That was something that we had feedback from our customers, and so we acted on that and at least made one scenario available to you where you can do some easy testing with this. Quick demo on this. Let's go out to JavaScript for this one. And I'm just going to let's just do a search on the timestamp. You can actually search on a timestamp, and you can see here, I've got the indexer client. I'm going to be talking in this case to the PureStake one, and I'm going to feed in a start time and the address. And so this is great if you ever have to verify an account or when this transaction occurred. And what you'll do is you'll get back the information on the block log to go ahead and do that. So I'm just going to run this command here for search transactions, and it's going to come back and it's going to go ahead and print out the information down below with that information in the console log right down below. So that is the transaction that this thing hit. And then, there are many other examples, right? You can search the block info. You can search application IDs for smart contracts. You can search, there's a lot of asset type searches. You've got searching by asset name, for example. You can search by minimum amounts. And paging, right? You can have a return, you can get a result set that's fairly sizable. So if that's the case, we will give you the ability to page through, and you have a loop process example here with the next token function. Okay, so let's get back to the deck, wrap things up for you. And I do want to call your attention to a great newsletter. Go out to at the footer of the developer page. There is a newsletter link, and actually Ryan publishes this on a weekly basis. It really tells you everything new going on in the developer world for Algorand. And so I encourage you all to go out and sign up for that as a great resource. Community project is also a community page under the documentation. And you can see all the other SDKs that are available. There are SDKs available for Algo, Algonaut, simple Algo API wrappers. We actually have a developer hours coming up on Tuesday on Reach, which uses JavaScript to develop applications and create, smart contracts, all that kind of stuff. I'm so looking forward to that session. That'll be on Tuesday. I'll give you the link to that in a second. I also want you all make you all aware of our ambassador program. We have over 500 ambassadors. These are like our most valuable professionals at Algorand. If you're interested in becoming one of these, I have a link I'll show you in a second to do that with. And this is the you have the Developer Awards Program, or DevAm, and the Algorand Developer Ambassador Rewards. So the Ambassador Awards will allow you to publish tutorials and articles on the Algorand site in the developer portal. The Developer Awards Program can be used like the C# SDK I showed you. We rewarded that developer with rewards from the Developer Awards Program. And then also, if you are an ambassador and you do host events or you do write blogs and things of that nature, you can get rewarded for doing those. A very popular thing has been the grant programs of late. We have a lot of great grant proposals in the works, and other ones that have been received through fruitions and as well. And you can see the whole list of grant recipients there publicized by the Algorand Foundation. And the Algorand Foundation is the organization that's responsible for token distribution. It's its own entity. Ryan and myself work for Algorand Inc., which is the technology side of the house. So that's a little bit of a differentiator. So anything to do with tokens comes out of the foundation. This is the link if you want to get more involved. Contact Stephen Dugnan at Stephen@Algorand.Foundation. Love to have you on board. A couple of great videos for your homework assignment. There's really a great video on Teal, another great one on Pure Proof of Stake, especially useful for the new folks that are on board here. And this is the code. Where's the beef? Right here is the code. We got two different sources. One of them I already showed you, which was the Algorand docs examples. The other one is the site that I maintain is on the DevRel site, the hackathon site. That one has that PyTeal example I just showed you, where I step through everything. Most of them are on both of these sites, but the key difference is just how they're organized. The first one is organized by feature, version, and then language. And the one on the hackathon is by language, version, and then feature. So if you're developing and you really just want to see very easily all the features, go out to the hackathon site and you can do that as well. All right. In summary, we saw a lot of great things here today in terms of blockchain use cases. Many to kind of give you a feel for the types of solutions. Again, emphasizing it's not just financial applications. Many different vertical silos can benefit from solution development using blockchain. Layer one features, man, we have a ton, right? We talked about Algorand standard assets, building your own tokens. You can build, of course, solutions programmatically with the API using Algorand, analogous to what I showed you, very similar in the AlgoDesk IO demo. Also, we got smart contracts that really facilitate logic, is really part of the signing process, as well as I call it a glue technology. It glues things together, atomic transfers with several technologies. And that's really what you need to do and understand thoroughly for solution development. lots of great tools, right? We dove deep into 4 different SDKs, the Go, Python, Java, and JavaScript SDKs, examples on each of those. And we continue to evolve with more languages and support through the community, including the C# SDK and REST APIs, right? We actually have a run in Postman link on the API page, so you can just very easily start doing some REST API call testing. This is the link to developer office hours coming up on algorand.com/developers coming up on the 15th. We have Reach, and I believe the 22nd, Jason's going to be walking through one of his solutions, and that'll be a good one to attend as well. So we have those coming up next week and the week after. And I wish everybody happy holidays after that. I am going to leave with this slide here. And I'm actually, well, let me post this into this one here first into the, I'm going to post this one into the chat window. And I would very much appreciate if you all can answer that. Let me just stop sharing 1 second. I'll come back to this chat window. Please fill out this survey because I like to make things better as we go through it. And if you have any comments and suggestions, I would really appreciate it here. So I'm going to go ahead and put that link into the chat window. I'm going to go ahead and then reshare my screen so you can have all the resources on there to end this with. And I'm going to go ahead and bring this back up. And there we go, share this. All right, now you should see my screen once again. And Ryan, do you have any parting thoughts? And do you see my screen okay?
Yeah, everything looks good, Russ. We had lots of great questions. Thanks everybody for participating. Definitely join us on Discord. Come to our office hours, and we look forward to connecting with you and helping you build on Algorand. Thanks very much.
All right, with that, we are exactly an hour and a half. How about that? Again, round of applause for everybody involved here, and thanks so much for having us present at the last slot of the conference.